Paseka is a researcher with the CSIR, and some time back he joined Load Research Chapter and started to listen in. And then we heard that he was getting into electric water heaters. Subsequent to this, Paseka has made a considerable amount of progress, and he's currently at University of Stellenbosch working towards his PhD, and he has done a pilot project at CSR on the attributes of electric water heaters. And Paseka, this is a subject that comes and goes on the domestic side, but not much on the industrial and commercial side. So I'm really looking forward to what you have to tell us about your study of demand flexibility on this side and this particular appliance. So without further ado, I give the floor to you. Please go ahead.
Thank you, Marcus. Thank you, everyone. This is such a great opportunity to share the work that we did. It's been years, but yeah, the work is still continuing. We are seeing some gaps and trying to address the gaps within demand response and demand side management in the residential sector. And currently, we are doing a great work into understanding how this demand flexibility can be implemented even in other sectors as well. So I've been working for the CSIR for the past 5 years. So the work that I'm going to be presenting, as Marcus has alluded, it is the pilot study that we did with the GISA here at CSIR campus. Basically, what we're trying to understand is the business case and the technical feasibility of implementing direct load control on electrical water heaters. So the results that I'm going to be putting up here is the results of the study. I'm hoping that this is going to be one of the shortest presentation that the Load chapter has ever had. I have 15 slides, and I'm going to try by all means to be as clear as I can. And please, if you have any questions, just feel free to shout, or maybe even at the end of my presentation, you can ask them, because I'm on a full screen, so I don't see when the hands are putting up, when you put up a hand. So before we embarked on this particular project, we had to understand the landscape, the energy consumption landscape of South Africa. And then we then realized that the residential sector, there's so much opportunities that can be harnessed on the residential sector. There's a couple of work that we are doing also in the industrial sector, but then this is not going to be from part of the presentation. I hope in the near future we will share the work that we are doing in the industrial sector, especially when it comes to energy efficiency and understanding the possibility of and the potential of implementing demand response in the industrial sector. But then this work is limited only in the residential sector, realizing that it consumed about 27% of energy consumption in South Africa, and realized that the greenhouse emissions, it was the residential sector was accounting to about 25%, and we saw that there is a great opportunity to reduce the CO2 through energy efficiency and behavioral change. Doing that, understanding that the buildings are consuming about energy, what is the total household consumption, understanding that landscape of energy consumption in South Africa, when we realize that we need to have a little bit of a breakdown in terms of the appliances that are used within the household, then realize that the uncontrollable water heaters accounting to 27% and controllable ones accounting to 8%. So together, water heating, it was accounting to about 35%, counts about 35% of our total households energy consumption. And then realize that there are so many things that can be done in this particular work. And one of them was just to see how is the control and the implementation of demand response could be in water heating. And then the objectives of the study, as I have explained, that we're trying to demonstrate the load conservation and load shifting control strategy of literal water heaters. We understand that there are about 5.4 million electrical water heaters in South Africa, consuming about 3 megawatts of electricity during peak. And that the aim of the study was just to demonstrate how the control of water heating can be very beneficial during the peak, and also switching off water heating when not necessary, and trying to see if both the control strategy could be implemented, what would be the benefit, and from the energy cost savings, from the energy savings and the cost savings, depending on the type of the tariff that you will be billed under. But the emphasis, really, it is not about the tariff, as you know that sometimes in the residential sector, time of use tariff is not really implemented in the larger scale, or maybe it depends on how big or how you consume electricity. That's when you get different what are the tariff structures. So it is basically trying to see how the shifting from the peak can be achieved, how much can be shifted along. This work, Marcus, as I said, it was a pilot study that we did in the CSIR. The CSIR is a big campus, and we have quite a large number of water heating, ranging from 100 liters to 300 liters. And the study was also, we had an opportunity to do the study again in the municipality scale, even though I don't think it is not going to be forming part of a presentation, because that was a project. It was not a research project. It was a project with one of the municipalities trying to understand, trying to give out an understanding of the the impact of demand response in water heating, and it was an incredible study that we did there. So the methodology of the study, the first thing that we needed to do was to connect connect controllers into the geysers. The controllers, what they did was to measure the flow rate, was to measure the temperatures, the ambient temperature inside and outside, was to also measure the power consumed with the water heating. So the reason why we did that, it was basically to understand what is the base load energy consumption of water heating in this entire CSIR campus. But then this is just going to be for the geysers that we installed the smart controllers on. So this is basically the average profile of the 200 liters. The data was basically collected throughout different different seasons, which is summer and winter, and we have this particular load profile of, this is just the geyser consumption throughout the week, and average. And what we realize that it is that we as a CSIR, we have quite a different scheduling in terms of when people come to work and when people leave to work. When people leave work, and we don't work on weekends. But what we realized is that there was no type of a scheduling on these water heaters, even though they consume so much in the campus. So what happened is that we had to employ a schedule. The best thing of the controller that we got, it was that you can access the online platform and switch it on. It's so smart in that particular sense, in a sense that you can put the schedule on depending on when you want it to be on, when you didn't want it to be on. So this was just to demonstrate the impact of strategic load conservation of geysers, considering the fact that we realize that people come to work at 8 o'clock and they leave work at 4. So the scheduling was like, okay, let us just put it from 5 o'clock up until 5 a.m. in the morning, up until 4 p.m. in the evening. The reason why 5 o'clock is because it takes time for water to heat up, and sometimes depending on the weather, sometimes it would take an hour, but so we needed to take into consideration that there are people that come early at work, and they utilize water to shower and to do other work in the lab. Sometimes it's the lab, sometimes it's the cleaners wanting to make things ready before employees come. So the reason why that's the reason why we said 5 o'clock, and the 4 p.m. is because everybody was leaving. And just to understand on what was the how could the implementation of a low strategy be of a benefit to the CSIR. And the results that we got, they were quite interesting, realizing that on Mondays, I will explain what happened on Mondays, but then the maroon, it is basically after implementing the controller, and the green, the blue, it is before implementing the controller. What we see, it is that when you take the average of these, this is summer week, where we see that there is 36% of energy saved per week if we were to employ that particular strategy. So in Monday, we, as you can see, that we switched it off on weekend. So there is what we call a cold load pickup. The cold load pickup, basically what is happening is that the water will actually go to a very low temperature. So to heat it up, it will actually consume more. So that is very important. And now that we are studying what would be the impact of cold load pickup should this be implemented in a larger scale. So yeah, that was one of the reasons that we picked up, which is one of the gaps in the studies, and understanding that the cold load pickup is very important, more especially when you trying to employ any strategy. One thing that we need to understand is how would this impact should, for example, every geysers comes in on Monday at a particular time, and that just gonna be too much. So that is a point that we highlighted in terms of the things that we needed to in the further studies, and we see the reduction of, like I said, 36% in energy consumption per week employing that study, and that was quite good. In terms of the fact that on Tuesdays up until Friday, we see that huge reduction. Yeah, so winter, the same, but now the cold load pickup is slightly higher. So this is what happened is that we also see the same 36% of saved per week. However, one thing that we realize is that the winter peak load is quite huge. So now the strategic load conservation, we demonstrated it. Now, the second one that we wanted to demonstrate as per the objective of a study was to understand how then load shifting can also be implemented to do this, because you can actually do that scheduling on the website, on the web page of the controller. So now we then realized that the CSIR is built on the time of use, and usually the peak load, this is where the energy it is very high, and there is so much that we need to do to reduce that peak load. So now from 7 to 9, we employed the load shifting. So basically what we did was to shift the load. This was into consideration looking in terms of the user's comfortness, because we didn't want to impact on their water consumption and their the style of their work, or however I can explain. But then the controllers were also installed in the convention center, CSR convention center, where sometimes it is very important to have water at all at particular times. So what we saw the results of these was to switch off at least during the evening peak. which is from 6 o'clock up until 7 o'clock. Anyway, it was still switched off. So what we needed to understand was from 7 o'clock up until 9 o'clock, how is the usage and how can we curb that usage? And implemented that control there. And just to see, and also what was important was to realize that the cold load pickup doesn't fall within the duration of the peak load. So now the controller that we implemented was to say, was in this particular format that we had to understand how water within a tank is being preserved, how the temperature of the water inside the tank is preserved throughout the day, so that when we do the shifting, it doesn't actually impact the user's comfortability. And what we realized is that by just reducing that from cost-wise, because as I said, that the CSIR is under time of use tariff, we realized that both the control strategy, if we to implement both the control strategy, which is a load conservation and load shifting control strategy, we would save about 41% of terms of the cost. It takes about 4 to 5 hours before, for the water to go into a minimum temperature. So this was important for us to understand that should we switch them off and try to implement this strategy, how long does water become stay hot within the tank, and so that people can still have they can still have hot water when they need it. So what we realized is the first thing that we needed to do was to do a little bit of a literature review, or maybe a review of the controllers, the existing controllers in the market. And the first thing that stood up for us is that water heating is roughly 18 to 37% of social grant. And as the high cost of electricity is rising, you would see people actually people at a very low income spending so much of their money to buy electricity. So it is very important to come up with energy efficiency solutions to do this. But then the energy efficiency solutions that you come up with, they must be cheap, or maybe they must be affordable to the people. So the access to control and the cost of the existing controller was the main challenges that we picked up. And another thing that we picked up was that these controllers, they are just smart switches. Like you can just literally switching on and off. This is just smart switching, but without intelligent capability within them. So the next work that we needed to do was to see how the implementation of machine learning in terms of understanding how water is consumed is important, so that the controller can switch on and off based on your historical water consumption and how you have been utilizing water. So this is not just the work that we are doing. We then realized that since that there is a high penetration of renewable energy, this is actually part of the work that I'm doing in my PhD. This was before, but this is how I picked up the gap into the study, of which it is the reason why I'm doing my PhD with University of Stellenbosch, was to say high penetration of renewable energy. We know that there is going to be some variation in terms of the production of energy from renewable energy. Sometimes it's windy, sometimes it's not windy, sometimes it's sunny, sometimes it's not. But then how can we use water heating to facilitate that high penetration of renewable energy while saving cost at the same time? So this is the work that we are doing, of which the results of the work that we will be, the results of the current work are about to be published. The drafts are run, models are being developed, and we will then see how does that gets to deal with the challenges of load flexibility and other challenges like cost. How do you implement this to cut the cost or to reduce the cost of hot water heating? Also, how do we use this as municipality level to to implement the demand response and the high penetration of renewable energy, considering the fact that there is that interchange. So that is the work that we are currently doing as CSIR, and I'm doing that work with with the University of Stellenbosch in the Department of Electrical Engineering. So the results of that, it's something that I think in the near future we will then be releasing them, and just to see in the bigger picture how it is. But it was the study that we did for the CSIR was just to understand the benefit of employing controllers within what water energy consumption, and we saw a very great savings, and we believe that there is a great savings that can be achieved within other sectors as well, especially when it comes to residential and domestic areas, where there is a lot of work that still needs to be done, and also how to develop these models, considering the fact that immediately when things are becoming when you employ it in the domestic area, we have so many variation, and it's not going to be easy just to say and train in the model. There's so many things that we need to look into that. This is the end of my presentation, and hopefully the further work we will be sharing and just trying to see how the results of this work turned out to be. Thank you very much, Marcus. Like I said, it was the shortest presentation.
Paseka, it's. I think the presentation might be short, but the discussion might be longer. Thank you very much. A very interesting presentation. I see we have a question from Mondi. Mondi, go ahead, please.
Yeah, thanks, Paseka. I just have a question or two. So I think the first one is just in terms of the sort of the pilot that you used, or where the model that you used at CSIR. Is obviously the load and the behavior there is not that of a domestic. How do you draw parallels between that and now a domestic customer? So let me, you can just note the question so that I give other people a chance as well. Then the next one is the customer experience, and I think you called it a comfort level. The customer experience, how did that go? Because I think as much as the technology itself would work, but I'm thinking in my house, if you were to switch off water at certain times, so we switch off water at certain times, so it means we need to adapt. Is there any sort of incentive that would, go with ensuring that the customer, the end user, is actually attracted to that, and even if there is a level of discomfort, they are still willing to take that level of discomfort. Then the next one is you have that stats which says I think 18 to 37% of the household's income, the SASA grant, that is what goes to the expenses of water heating. Are they the beneficiaries? Are they a target market when it comes to water heating? I would have thought that they would not normally have geysers, because it just it's almost impossible for them to have that. And then what normally happens when you have a study like this is that people tend to focus a lot on energy and the savings and all of that, the kilowatt hours, which then you convert it into rands, etc. Any aspects of the power now, the power side of it. So because I'm thinking, for example, if you are looking at a certain, let's say a certain neighborhood, and in that neighborhood, you install these devices. When they switch off, I would think that, in terms of your voltages, and the quality, the power quality at a local scale, from the feeder level to the substation level. Well, is that an aspect that because it really happens a lot that the forecast is just given on energy, but not the power side of things. Thanks, Marcus.
Thank you very much, Londi. That are 4 questions, and I'm gonna try by all means to answer as I can. So the first one, the last one that you mentioned, where you spoke about the first, what is it, the stability of the power system as we switch on and off and on off. I think there's a part where I addressed the issue of this you being utilized pretty much from the municipality level where there is high penetration of renewable energy. From that perspective, not really from the perspective of how the inertia of the generators from the supply side are going to be impacted on this, but then literally only looking in terms of how can this be facilitated, just to facilitate the renewable energy as they shift on and off. So that's the perspective that we took when it comes to the power flow and this the power system analysis of these, just to address the issue of instability of renewable energy and how this particular technology can be utilized to address that. I think you mentioned so many things when it comes to the challenges of the the switching, of which at this particular point, the study didn't. Our study, actually, in my study currently at the university, I haven't really gone into a point whereby I do the technicalities in terms of how these would have an impact in the generation of electricity. And I think that one I will note it down. Then the second question that you had was you talking about you asked about how is this particular study that we did and is going to be relevant into a domestic sector, considering the fact that anyway the utilization of heating, it is with utilization of water is not the same. I think that question I can answer it by saying that we installed some of the meters, some of the controllers at the guest houses here at the CSIR. There's the guest house places here at CSIR. So we've been monitoring that, and we are developing that training model, like I mentioned, that this is not going to have an impact on your utilization of water or the comfort level, but then it will learn how you are utilizing water. And also, the reason why we did this study was just to highlight the benefit on the potential for these particular controllers, that we really need to get into a point whereby we learn how to manage energy in that space. And our study was just a piece of a pie that, this is going to be, if ever we were to go and address, or maybe just to find the potential in industrial, in domestic, or maybe in the residential sector, we will still find out that there could be potential where water it is not being utilized optimally. And that was the reason why we highlighted these issues, that we can take the study and analyze how water is being consumed in the domestic area. Like I've explained that in this, the controllers were also placed in the guest houses at the CSIR, just to understand, just to have a little bit of an understanding of how the domestic sector is consuming water, and how can we employ such controls. And what we realize is that in most of the cases, people will be, the ESCOM used to have what you call the ripple relays that were connected on the people. I think there's was City of Johannesburg did the study of the ripple relays, but the problem about this is not a problem as per se, but what we are proposing is, can we have an automated system, an intelligent system? How can we incorporate artificial intelligence into controlling of energy management within the domestic or residential sector, and there by seeing what would be the impact. And from a fixed point of view, like you mentioned, that sometimes you wouldn't be having water, whereas you needed water. And you also mentioned that you also asked the question about what would be the incentive by participating in this. Unlike in the industrial sector, whereby the customers that are being incentivized by reducing their electricity consumption and all that, this wouldn't have any impact. We assume that this won't have any impact in terms of how you utilize water. However, it will learn how you utilize water and optimize how you use water, switch on and off based on your historical use of water consumption. And these models will rewrite themselves in a sense that immediately when you've changed your utilization, or maybe you have changed the way you use water, it will adapt into it. So yeah, I think by answering I answered your questions in that space. I don't know if because there are people that have had their hands up. Still, yeah.
Paseka, I don't see any other hands up, but if I can just pop in with a question of my own. Okay, I see two more hands up. Let me defer to them. Corin, you first, and then Lloyd.
Thank you very much, Paseka. Interesting approach. I'm glad you actually referenced the Eskom ripple relays, because I'm very interested to know what actually happened with the studies that they did. But okay, that's not part of your study at this stage. The artificial intelligence, I'm very interested to know what you will include in your study. Just purely the people reaction, or would you also consider what the network can supply at that stage? Because obviously the network will be able to supply much more at certain stages than at other stages. So please just add, how wide will your artificial intelligence information gathering go? Thank you.
Thank you very much. That is a good question, basically. By the way, so now when we look in terms of what will be training the model, so the first thing that we needed to do was to understand the user's comfortability. That's the first thing that we need to understand. Then the second thing was just to understand how water has been consumed in different regions, and also according to different seasonality, and which is the temperature that is very important in this particular case. And also understanding how I think this is where we need to include the different studies. I think Monde, I forgot to answer one of your questions about that sometimes, the people that are on social grants, they do not afford geysers. We get to a point whereby the RDPs these days, they have, they actually install a geyser for you. There are some instances, the study that some areas where the RDPs comes with the geyser itself. So we took that into consideration, and also that sometimes, the economy went very, very to a point whereby it impacted so many people and their incomes. So sometimes people that used to have, in some cases, people that used to afford certain things, they can't afford them anymore because of the impact of the economy and other variations. So there is that market that still needs to be addressed. How then do we get into assisting the market that really it is very low? The low-income households in that particular space. So I think I will classify them as a low-income households. So yeah, there is a huge market even in there. I know that sometimes in most of the cases, how we previously the low-income households, things like geysers wouldn't be something that they have, but in some cases they have, and in some areas now, we see that the government is doing very well they are trying by all means to have the RDPs installed with these appliances. Yeah, so current when out or the current so your issue in terms of the frequency stability when there is high power into the power system. How do we do that? This is basically where it's going to be in a position where I was explaining that we want to try to incorporate that is one of the training of the models that should there be a high penetration of renewable energy, even high energy into the power system, the switching of geysers can be turned on so that the power can be consumed by the geysers. So basically what we can do, we are using them as storage devices in the particular case. Whereas when there is a particular point whereby there is a shortage of power, of course, it will have to look in terms of how people are utilizing water, then switch off geysers that are not going to be necessary, and by that it will all be optimizing the power system in that case where there is shortage of power. I think I tried my best to answer that one. Is the next one, Marcus?
Thanks, Paseka. Lloyd, your hand is up.
Yes, Marcus, thank you. Thanks, Paseka, for the presentation. My question is very simple, and I think you'll give a very short answer. As far as I remember, these water heaters, they do have the thermostat. Now, in one of your slides there, you had an issue or a problem of a comeback load on Mondays. Haven't you tried to see if maybe you switch on your geyser on maybe Sunday afternoon or Sunday evening with your controllers, but then just limit the temperature of the thermostat to lower levels so that at least when Monday comes, you don't have to sort of heat up the water from the very low temperatures. Let's say for around 15, 20 degrees Celsius. Thank you.
Yeah, thank you very much, Wade. I think you are addressing a very good point where you saying that, like I was saying, that this was just a strategy, a control strategy that we were trying to see the impact, not really saying that this is what is going to be employed. So we had so many recommendations and also so many studies that went about. There's some things more like a geyser blanket. How put geyser blanket? What would be the impact in terms of the load coal pickup in that particular space, or maybe even trying to understand that whenever, like you mentioned about the thermostat, when the temperature of the water goes beyond a particular temperature, at least it heats up a bit and switches off a bit, so that immediately when we get to be on Monday, the water is not heated from a very minimum or maybe an ambient temperature, but then at a particular temperature. That also we need to look into at a particular the studies that we are doing in the particular case, in this current case, of which we looked into that. Like I was explaining, that there are some solutions that we looked into. Where geyser is being situated, the way the horizontal, vertical, on the ceiling, where it is, the geyser blankets, all these particular parameters and solutions were looked into and trying to find the optimal scenario whereby the coal load pickup, it doesn't fall, it is reduced and it doesn't fall within a peak load. Yes, Marcus, I think I did answer that one. I tried.
Okay, Lloyd, are you happy with that answer?
Yeah, in the interest of time, Marcus, that's fine. Thank you, Paseka.
Okay, thanks. I have a question, Paseka, I'll put to you. You mentioned an estimate of about 5 million geysers. Now that's interesting because we have roughly 18 million households in South Africa right now, and most of them electrified. And 5 million sort of sounds like a reasonable estimate as to the number of geysers. But the interesting thing to me is the nature of those geysers and sort of how well they're maintained. What we saw during the course of the domestic load research was that even though some RDP houses had electric geysers, electric hot water geysers installed, as you went down the wealth levels, even though those were supplied with a house, there was a chance that you'd start running into houses on the poorer side of the scale, which had this technologies fitted, but they never maintained them. So, when the element went, the element wasn't replaced, or if the geyser got a hole in it, the geyser wasn't replaced. So there's a maintenance cycle there that inevitably leads to these things becoming unused or ineffective. That is one of the things, and you'll see that as you come down with your demographics, that even though they are nominally in place, they're not actually in use. Then the other thing which is interesting, and it's getting more interesting by the day, and both myself and Lloyd, I think, are worried about this, is the number of geyser technologies. You have the normal geysers, which are single element and so on and so on. Then you have multiple element geysers arriving, and then we have hybrid electric and solar geysers arriving, and then we have only solar geysers. So the hybrids have an electric element in there, and that element kicks in to maintain temperature as your air temperature goes down. So yeah, it's becoming quite complex, and I'm not sure if we have models ready for all of those things. Can you perhaps comment on that? Thanks.
Thank you, Marcus, for that question. Let me just answer. Let me start by answering your last question, where you spoke about geyser technologies that are in the market. Where you spoke about multiple element, single element, hybrid, solar, water heaters. We have heat pumps coming into play. What we looked into, it was the cost of these technologies and the adoption rate of these technologies. It is not as it's not as growing because of that is still expensive, and people usually, when you sell something of that higher price, and people see that when you model what is it, the payback period of such technologies, we, even though it's still a little bit, it makes sense, but yeah, we don't see the rise of these other technologies into the market, being adopted by the market. So it is very hard to also do the modeling in terms of that. But what we really looked into, it was how many water heating single models are there. So we have, you mentioned that, so the models are there that are, are are used to model the electrical water heaters. I'm going to be talking about two, which is a single node model and a double mode models that is being used a lot in modern space of water heating. And when it comes to solar water heating, it is still a little bit low in terms of the adoption, considering the fact that, when you have that panel that is on top of your roof, and also you maybe, because normally what would happen is that the class that has these solar heating technologies would be the middle to upper class, and these people could actually even afford the solar panel. So taking that particular part of the roof also, it is going to be like, yeah, it's one of the challenges that people have, that, I'm going to install solar PV, as we know that the country is going through so much in terms of load shedding schedules. And if you have to have, again, the space for solar panel for solar water heating on the roof, it will just be taking the whole space of the roof that you can use to generate energy for other things in the house as well. So yeah, we don't see a high adoption on that one. So when it comes to maintenance and operation and maintenance of the water heaters, this has been addressed a lot when it comes to energy efficiency. And I think we also did a lot in understanding how maintenance of electrical appliances could reduce the cost of electricity within. I think we did a good work in the tourism sector, where we looked generally in terms of the appliances that the guest houses would have. And one of the recommendation was to employ, or maybe to do the maintenance scheduling, so for these appliances like HVAC, and then even water heating and all that. So that one, it will be that point, it is addressed mostly in the energy efficiency. But yeah, this work for us, it's just more on the demand response. But yeah, I think that is a good point, just to highlight that we really looked into a particular sector, looking in terms of operation and maintenance of appliances, and what were the recommendations and what were the cost savings, and we did that, and it was good, and to see how the maintenance is still lagging within the domestic sector.
Yeah, noted. Thank you. We've got two more hands up. I'll give it to Evius and then to Karen because Karen's already asked. Go ahead, Evius.
Thank you very much, Paseka, for the presentation. My question was basically on the proportion of industrial compared to residential energy consumption. I see the industrial is sitting on about 36%, and then the residential is sitting on 27%. It looks just the industrial looks very small compared to residential. Did you confirm these numbers with other sources of information?
Hi, thank you. That one is very good one. So what we did was to have energy balances in 2015, and this was coming from the Department of Energy, looking in terms of that. So we also still have a little bit of questions in terms of the data on ourselves, but recently, because we did a study in terms where we do energy consumption analysis of South Africa. So that case, it would be. Currently, I think we are sitting at about more than 40% of the industrial sector that is being consumed, the consumption. I think I will just update this slide when I share it with Carol, just to bring up the numbers accordingly. But this was coming from the Department of Energy, Energy Balance, the 2015. I think, yeah, I did put a reference there. So if there was something that you feel like the numbers were not good enough, I think I can just rephrase it and just give up the numbers for the recent numbers, which is 2021. I think it wouldn't make sense now because of COVID and other stuff. So there's going to be a lot of shift and change. But this was pre-COVID, and the numbers that I will put, because I know that the website, they have the data till 2019. Or 2018 between that. So yeah, I will definitely do fix up the numbers if you see that the numbers are not correlating to the current studies, and I will update accordingly.
Paseka, you must be careful of changing around to satisfy the audience too much, because the fact is we don't really know what normal is anymore. With what's going on, I'm sure it's frustrating many of the planners around the table.
Yeah, it is. So much has changed.
Karen, you had your hand up, and then Thomas, and then I think we must close. Go ahead, please, Karen.
Thank you. Paseka, just a quick question. You're focusing on the water heating, which is obviously a major energy usage, but we're finding that air conditioning is also becoming more and more of a energy user, and air conditioning, if properly controlled, can also help to change the load profiles. Are you perhaps considering in future to look into air conditioning as well, to include that into studies?
Thank you, Karen. I think that one it has been in our books for some time, just looking at different loads and how these loads we can employ demand response energy efficiency in all these loads. And there is so much work that has been done in air conditioning. This is international studies, international best practices in terms of how do you employ the controls of what you call air conditioning. So we needed to find where there was a gap. That's the reason why we actually looked into water heating as compared to air conditioning, because there was so much on the literature about the control of air conditioning. So the reason why we looked into this study is because of that. Just we found the gap, and that there's just not many people that are doing some work in controlling of water heating. So that's the reason why our study mainly focused on that. But then we'll definitely be looking into all these other appliances that are consuming, the significant energy consumers within the residential sector as well.
Thanks.
Thank you. Last question from Thomas, if he's still with us. Thomas, would you like to voice your question?
Yes, thanks. Hi, Paseka. I just wanted to also
add on your consumption sector that I think mining is still the major consumer of electricity. So I think you should also consider it also in that sector consumption.
Yeah, thank you very much, Thomas, as well. I think I will take that into consideration. I will break it down because at some point, some of the numbers were, well, the sectors were incorporated and put together and on that. Yeah, so yeah, I will do so.
Yeah, Thomas and Paseka, this is I mean, just to keep something simple, it could be that some of these figures have been collated into areas that don't quite match the text. That's I think probably what might have happened. Paseka, thank you. It's interesting to see this kind of thing going on. It is a bit of a recurring story in the industry, but I think every time we go through one of these cycles, we learn something additional. You know, in the past, where we saw this, there wasn't a thing called artificial intelligence, which could control stuff. And more that's becoming the case, and the learning mechanisms and so on are improving. So I'm very keen to see the results that you might come through with for differently trained models, and on the same system, to see how it might optimize. I think that could be a very great advancement, and I wish you all the best for your studies, sir.
Thank you very much, Marcus, and everyone, for giving me the opportunity to share the work that we have been doing with the CSIR. And yeah, it is great to even the points that you guys have mentioned. I have noted them, and hopefully next time when I have this type of a presentation, if I get the opportunity, it will be very in detail.
Paseka, we look forward to getting you back in future with conclusions and more results. That would be very interesting to all of us around the table, I believe. Thank you.
Thank you.